You have seen that when two identical panels was connected in series, you have seen that each panel is showing the equivalent voltages since both panels are of equal rating, isn't it? Now we are doing the same experiment but with a different rating of panels. Now out of these three, now we are connecting the 100-watt panel and 180-watt panel. If both of this, if it is connected in series, now what is the wattage what you are going to get? 100-watt and 80-watt, both was connected in series. Now the load, it can be extended up to 180 watts. Earlier 280 watts was connected in series, so the power rating was done as 160 watt. So if you have a different panel ratings but operating at the same voltage, isn't it? Operating at same voltage but the capacity of the panel was different. So how to utilize that and how to extend your voltage? As I said you that earlier example, in a string, if you want to get the rated voltage, but due to some problem, if one panel is generating some less voltage, so by doing this type of arrangements, you can extend the voltage with a little bit more than that of the set value, so that even if the shading impact was appeared on that, because of that some voltage may be compromised, though you will get your exact output voltage, isn't it? So for example, if you want to get 400 volts, so the panel design, string design, it should not be done for 400 volts. That has to be done at 415 or 430. So due to any shading effect, if it occurs, some voltage it will be reduced. The final voltage what you are going to get will be the rated voltage of 400 volts, isn't it? So to do the same, we are connecting two different rated panels. If it is connected in series, but both are operating at 12 volts, isn't it? But as I said to you earlier, if two different panels was connected, each panel it is having different specifications. So let's take an 80-watt panel. This panel it is operating at 12 volts, 80-watt power capacity, and while coming to the current ratings, this has a capability of generating 4.7 current. Okay, whereas that panel it is having a 100-watt capacity, operating at 12 volts, but it can generate 5.7 amperes of current. But when these two are connected in series, what are the panel what it can generate the lower current, the same current can be given to the load, though that panel has a capability of 5.7, isn't it? So the current will be compromised, but the power rating can be, the capacity can be extended. Got it? So if these two was connected now in series, for each panel we have connected a voltmeter to know the voltage of each panel, what it can able to generate. And similarly for 80 watt, I have connected another voltmeter to check what the voltage what it is generating. When these two are connected in series, a summation of these two voltmeter has to be calculated, isn't it? So for the resultant value, I am connecting a one more voltmeter which can show the resultant of these two, summation of these two voltmeters. So both we will see that the difference, what is the primary voltage of 100 watt panel, what is the voltage what an 80 watt panel can generate, and what is the resultant voltage what we are getting. So in theoretical, the voltage should be equivalent to, the resultant voltage should be equivalent to summation of individual voltages what each panel can generate, isn't it? So in theoretical, V should be equivalent to V1 plus V2. So in practical, we will see that whether you are getting the same or not. So for the 100-watt panel what we have connected, here you are getting 80.5 volts. Similarly for 80-watt panel, it can generate 20 volts. So 20 plus 18.5, 38.5. So that is the resultant voltage what it is generating here. So what you can see on the meter. So as per theory, you already said that V should be equivalent to V1 plus V2, summation of individual voltages what it is generating. Practically we are concluding whether it is generating in the same or not by doing this experiment, isn't it? So coming to the concept of earlier case and this case, the current rating here, the maximum permissible current in this case, it can be degraded though you have used a higher rating panel, isn't it? Earlier we have used two same rated panels which can able to generate 4.7 amperes of current. but now I have replaced the existing panel with 100-watt panel, isn't it? Though I have increased the capacity, the current rating it is getting reduced. Got it? So because of this reason, whenever you are going to do any project, a large scale project, it is suggestible to select a same rated panels. Understood that? This is the conclusion what we can conclude. The same rating panels has to be chosen while designing a larger circuits. But in smaller projects, if the current it is not your primary criteria, then you can extend your power capacity, the load capability, by extending that with the higher rating solar panels. Understood the concept? Any doubts on this? It's okay. Thank you.
పడిపోర్లేబ్బా
రెండు 5.7 జనరేట్ అవుతాయి కాబట్టి సో అవుట్పుట్ కరెంట్ కెన్ బి ఇంక్రీజ్డ్
పడిపోతారంట
మరి హైయర్ రేటింగ్ ప్యానల్ నేను లోయర్ రేటింగ్ దాంతో కనెక్ట్ చేసినందువల్ల
we connected different rated panel. You see the parameters of the panel. So what is the rating of this panel? 80 watt peak. So this 80 watt peak solar panel is having a maximum voltage of 17 volts, okay, and maximum current of 5.3 amperes. Okay, so what is the maximum voltage is? Maximum voltage is 17 volts and maximum current is 4.7. So when you come to the higher rated, so this is of a higher rated, you can see here the maximum voltage is 17, that is also 17, this is also 17, therefore we can connect them in series or in parallel also. And current is 5.7, there it is able to support 4.7, but it is able to support 5.7, but the panel, this 100-watt panel is degraded in its performance, therefore 5.7 is in series and 4.7 also is in series. When two currents in the same circuit are of different values, which will come into the value which is of lesser magnitude, therefore the resultant current is 4 amps. The same we are demonstrating with the meters. So this is an 100-watt panel, this is an 100-watt panel which is indicating as 18 volts. This 80-watt panel is also indicating how much? 18 volts. So both are in approximately same value. So resultant is how much? 18 plus 18 is how much? 36 or 38 approximately it is indicating. But when you turn on the load, the resultant current is how much? One is 5.7, one is 4.7. Maximum we can load only up to 4.7. So this is loaded up to 4.7. Okay, so 4.7 into 17 or 4.7 into 20 is how much? 4.7 into 20. Okay, so maximum we can load only up to this. Now is it advantage? So which is advantages? Is it connecting same rating or different rating is advantages? Same rating is all the time advantages. It is not recommended to give this sort of two different rated panel. If you connect, what will happen, sir? That cost and the value what you invested on 100-watt is wasted. So this is 80 and it is also behaving like 80. If you have 100 also, its behavior is only equal to 80. So 20 watts is wasted in terms of investment. So that is the result and conclusion of this project. So recommended, while you design this for your electrical, for your house or for any commercial, you should have the same rated panel. You have to connect in series connection or in parallel connection. Voltage is mapping, no issue. See here, since it is 80 and 80, voltages are same, that's why at least we are connected in series. But for example, you have selected a 100-watt and you selected a 300-watt, we cannot connect in parallel. Why? Because two different values again. Okay, you can connect, nothing will happen, but the problem is whatever is the lower magnitude that will come into the effect. So that is 300, this is 100. When you connect them in series, what will happen? Completely will be equal to 100-watt. Why? Because this current will be leading than the higher magnitude of current. So this is the conclusion of this experimentation part. Okay.